Mm. All right, welcome everyone. We're going to give folks a few minutes to join. I will start off with a quick introduction. All right, cool. Looks like we've got a good amount of folks jumping in. So welcome everyone. Today's webinar is presented by Matt Meneely at Clark Dietrich. We are very excited to bring you today's presentation on fire-rated head-of-wall joint assemblies. This is a CEU approved presentation. I'll go over making sure you've got your AIA number registered with us shortly. To start off here, I'm just going to give a quick introduction about Acelab and show you how to access some more information about Clark Dietrich after today's event if you are interested. Awesome. So Acelab is helping out with hosting today's presentation. We provide free resources for architects and specifiers to research building products and to build out digital firm libraries to really keep all of that information accessible for you and your team. So I'm just going to show you a few things here. If you would like to come to Acelab after today's webinar to learn some more about Clark Dietrich and explore more about the products that they offer, you can always use this search bar at the top and just type in the name of any brand or product category. That'll cross search between all of our different resources. You can head on over to their page on Acelab. From here, there's a lot of great things you can do. You can connect with their team directly by clicking this contact button. So if you've got any questions you want to follow up with them directly about, that's a great thing to do. Explore some more about their company in general, and then explore more about all of their product offerings. You can save these into your firm library or into your projects on Acelab, and you can open up any one of these products to explore some more about product information, access downloads such as product literature, CAD files, all of that good stuff. So if you've got any questions, I'll throw my colleague's meeting link into the chat so you can sign up for a free demo with Acelab to learn some more. One other thing I just want to show you today, we will give you the opportunity during today's webinar to let us know if you're interested in getting in touch with the team from Clark Dietrich. If you say yes to that, we'll create a conversation for you so that you can ask them any follow-up questions. To get to your conversations on Acelab, you can just click this little conversation icon in the top right. That'll take you over to all of your conversations. So it's a great place to keep your research organized along with your communication. You'll also get emails about any new messages in Acelab, and you can respond directly to those. They'll log in Acelab's platform as well. So you don't need to come back here to respond. Last thing I'll show everyone today, if you're interested in gaining access to some of our newer features, we recently launched a schedules tool. And this is essentially a place where you can store a bunch of data from Acelab's system. So saves a bunch of time in setting up your firm library. You can just pull in data points that we already have. And you can also add in all of your custom data. So whether you want to set unique statuses, tag it with different project types, and you can also load your reps here automatically as well. So this is a great place to keep your product information organized, keep it accessible and collaborative with your team. So again, if you're interested in learning some more about this, I'll drop my colleague's meeting link into the chat so you can sign up for a quick demo with us. Our team will help you get all set up on our platform. All right. Before we jump into the webinar, just a few last-minute housekeeping items from me. This was a CEU-approved event. We did ask for AIA numbers upon registration. I will also send over a form in the chat momentarily where you can log your AIA number as well as request a certificate if that's something you need. Other than that, just want to encourage folks to please ask questions or submit comments to the Q&A throughout today's webinar. We should have some time to get to those live. And if we don't get to your question live, we'll have a record of it so you can follow up after today's event. All right, awesome. I believe that's it for me. Keep your eyes peeled for some of those helpful links in the chat. And without further ado, I'd love to pass it over to Matt to get started with today's presentation.
Okay, fantastic. Thank you, Bo. I appreciate the introduction. And I trust that if we do have some questions come through the chat, we will be able to get to those here at the end. Bo, if you see them come across and they're relevant to the current slides, feel free to just kind of speak up, and then we can also address it as we go, whatever works best for the group. So a few quick facts about Clark Dietrich. We are currently the only cold form steel manufacturer with a truly nationwide presence. We have 14 manufacturing locations throughout the United States, just over 1,400 employees. We also have 5 engineering offices. Our engineers specialize in cold form steel shop drawings for delegated design. So we participate in that on a regular and consistent basis with over 50 engineers currently employed. Something that I like to touch on, and it actually speaks directly to my role, is I'm a technical manager for Clark Dietrich. You can see that we have a figure up there that states that every state has an assigned Clark Dietrich rep. You also have an assigned Clark Dietrich technical representative. There's 5 of us spread throughout the country, and we field questions every day regarding wall heights, STCs, UL ratings, and the list kind of goes on and on. We can provide a little more insight beyond what just the scope of our testing and published information addresses. So if that's something that you need in the future, please feel free to reach out. We'd be glad to help you with those technical situations as well. You can also see we have several digital tools that we offer. If you have not been to ClarkDietrich.com, I definitely encourage you to go out there and check that out and take specific note to our iTools platform, which has wall lookups and submittals, as well as fire and sound lookup information included in that platform as well. With that said, are there any questions thus far?
Looks like yeah, I think you might need to reshare your screen. I think they're not seeing the slide.
Oh, shoot. Okay. I'm not sure what happened there. Let's just, maybe whenever it jumped over to you, it may have taken it away. So let's just share this again and go from there. I apologize for that.
All right, awesome.
So there is the slide. Can you see it up now, Bo?
I can see it up. Yep, looks
Okay,
good.
perfect. So I already spoke to a lot of that, but I'll leave it up for another second or two just so you can kind of digest it. Again, the main key points being we're a national steel framing manufacturer. We do have engineers and technical representatives that are a resource for you in every state throughout the country. And then we also have a robust website at ClarkDietrich.com with a lot of valuable tools and information, such as wall lookups, fire and sound information, and the list kind of goes on and on. So I definitely encourage you to check that out. As Bo mentioned, today we're going to talk about fire-rated head of wall joint assemblies and some considerations for design professionals here by the end of the presentation today. Bo did mention that it is an AIA continuing education program. You can see the course number there, and this is for a 1-hour learning unit for HSW credit. So the main learning objectives today are going to be what constitutes a fire and smoke rated joint assembly. We're going to explore steel intumescent fire stop and how that's used in various construction assemblies. We're also going to review some test standards, specifically UL2079 and the 4th edition UL2079 and the 5th edition UL2079, which incorporated a code change. We'll talk more about that. And then finally, we will break down a few head of wall UL assemblies and kind of define that and talk about that a little more, kind of jump into that and show you some of the specifics behind some of the intumescent steel products. And then finally, by the end of the presentation, hopefully we've given you some good considerations for detailing those fire and smoke rated joints. So again, to start with fire and smoke rated joint assemblies, what is the head of wall assembly comprised of? It is comprised of the substrate or what we're framing up to. In this case, this particular slide shows a flat concrete deck. Number 2, the head of wall assembly is also comprised of the top of wall deflection or perimeter edge framing system. And then finally, number 3, it is the fill void or cavity material protecting the joint. In a fire rated wall assembly, in a deflection condition, we now have a construction joint that's exposed above the gypsum board, and that's what we need to fire protect. So what is the perimeter joint? It's essentially the distance right above the wall board there. You can see the gypsum board up the wall, and there's a gap left for deflection. That's the perimeter joint that we are trying to protect. And you can see the official definition per IBC 2021 over there on the left-hand side of the screen there. But that's in a fire-rated wall assembly. That joint highlighted in a red box there is what we are trying to fire protect. Common joint substrate types that we frame up to, you have flat concrete as previously illustrated and illustrated in this slide here as well. You also have fluted metal pan or precast fluted deck. This assembly, you can see there's mineral wool plugs stuffed into the flute openings above the top track or the top of the wall assembly. You can also see a black strip just below that mineral wool. That's the steel, that's the intumescent strip on the steel track. And then you can see the wall board. So that was a fairly large, joint size there, protected again by the intumescent strip running underneath the mineral wool flute plug to fill the flute cavity there as well. And that is completed as you see it installed there. These particular ULs do not require any fire spray over the mineral wool flute fill, and they also do not require any fire caulk because you have the intumescent strip protecting that top of wall assembly. And we'll continue to talk more about that throughout this presentation. Structural steel support beam is another substrate that we frame up to. This particular picture, you're looking at the inside of a shaft wall assembly. So you have your liner board there inside the CT shaft wall studs, and then you have your steel deflection track at the top, which you can see in this case is a slotted track, and then you have your steel intumescent strip on the outside of the steel track. And then finally, we have mineral wool stuffed up inside the top track here, and it keys in over top of the liner board. Therefore, you don't need to fire caulk that joint because you have your steel intumescent strip, and then you have your mineral wool to help further protect that area for smoke as well. Typical head of wall deflection systems. Deep leg track, item number 1 on the left-hand side there, is a very common way to achieve deflection, or I should say to receive deflection by steel frame systems. And you can see it's just a deep leg top track. Now in that detail, you do not want any screws running through the leg of the track into the stud. If you did have that screwed off, you would prevent deflection from taking place. So our method of attachment is to drop 12 inches down and install a lateral bracing bar. In this case, it's cold rolled channel, and that cold rolled channel is clipped to each wall stud with screws making the attachment to the channel and to the stud. Item number 2 is a slotted track, another common way to achieve or receive deflection for the steel frame systems. That slotted track has a slot on both legs of the track, and typically the screw is centered through that slot. So you do make a screw attachment there through the center of the slots on both sides of the wall stud, and that permits the framing to receive that up and down movement. And then finally, item 3 is a T-shaped track. It is a larger member with a lot more steel in it. So typically we rely on these T-shaped tracks to accommodate larger amounts of vertical deflection. I'm going to show you a brief video here, and I believe the audio will come through as well. Yeah. So a few key things about that video regarding the T-shaped shoulder track. You probably did notice some fire caulk above the drywall rip at the underside of the deck. That's because that T-shaped track does not have intumescent tape on it, so you do still have to fire protect up above the drywall rip to the underside of the deck there. You also noticed a couple clips possibly on each side catching the inside return of the steel stud. Those clips can be required for just increased loading requirements where we're taking a bigger reaction load at the top track. We also have tables without the clips as well. You just don't get as good of a capacity out of that. So with that said, continuing on, some common fill, void, or cavity materials used in joint protection is what we're going to talk about next. They could obviously be mineral wool-based insulation. It can also be fire caulk or fire spray. That's uncured materials that are typically applied in wet states. It could also be drywall. We can fire protect with drywall or rips of gypsum board as well. We also have flute plates. Those flute plates are typically used in conjunction with mineral wool based on the design of the flute plate itself, and those are commonly used when you're running parallel with the flute opening. And then finally, you have fireproofing, cement or fiber-based spray-on materials, and then you have the Steel Intumescent Fire Stop that's also an acceptable method for joint protection as well. So first, our compressed mineral wool. We state in this slide it's to prevent air leakage on the fluted pan deck, and that's really what it's for. The leakage rating we'll talk a little more about, but that's essentially your smoke rating. So we use compressed mineral wool to fill the flute openings above the fire protection, which in this case is the steel intumescent strip, and that's that black strip that you see at the valleys of the flute there. And then the wall board or the gypsum board comes up over and over, always overlaps the intumescent strip, minimum 1/4 inch, even when that joint is fully opened up. Fire caulks, fire sprays, you can see they're obviously applied in wet, uncured states, and they're typically applied over a backing material such as mineral wool or foam backing rod, depending on the joint size. They do have some elastomeric properties. They are also in the joint itself, so they fill the joint, whereas the intumescent tape doesn't really fill the joint because the drywall can overlap the intumescent tape and just kind of ride up and down the intumescent tape in a deflection situation. However, the fire caulk is actually filling the entire void above the gypsum board. Therefore, you have to watch the percentage of movement that these products have, and they will vary. Some will only have 20% movement, others will have up to 50% movement. So the end result in that is typically you'll have larger joint sizes when you use some of these fire caulk and spray on applied materials. Here you can see a spray applied material, cementitious fiber or something over the mineral wool flute plugs there in that highlighted green area. And this is where the mineral wool was likely not oversized, so it was not compressed. It was probably like a flute plug that just sat in there loose. And in those conditions, they do have to spray over those to lock them in. The intumescent tape on steel track UL assemblies are based on mineral wool being compressed and friction fit into the assembly. Therefore, you don't need to spray if you're following some of those intumescent tape UL assemblies. Some caulk and spray considerations. I already mentioned it before, but they typically require larger installed gaps to address the filled joint and the flexibility of the material itself. Manufacturer's recommendation is always to apply that material to areas that are cleaned of loose debris. A common thing that occurs is we'll see some failure points with caulking materials because as they cure, they tend to dry out and shrink. So when they do that, if they're attached to, a cut piece of gypsum board, for example, gypsum board dust is kind of like baby powder. It's very difficult for anything to stick to it. So when it's curing or drying, it'll sometimes pull up away from that gypsum board. So that's a common failure method and something that we see on a consistent basis. There's also temperature range requirements. So you have to have buildings that are temporarily heated in the wintertime to apply a lot of this, the fire caulking and spray on fireproofing materials as well. There's also off-gassing considerations in occupied buildings, for example, hospital renovations, so on and so forth. And typically, Fire caulking and spray materials require additional rework because the trades interfere with some of the material, or due to obstructions from those trades, difficult areas to access and get enough fire caulk in there. So those are just some of the common considerations that we see with both fire caulking and fire spray. An example of some of the failure points here in common disadvantages. Concrete, sometimes concrete has a certain level of dust in it, or the concrete deck undulates slightly. So sometimes we'll see that adhesive failure where the caulking material will pull down away from the concrete substrate above. Sometimes we see cohesive failures as the deflection continues to cycle, and that wall assembly continues to receive the deflection from the structure. That eventually wears out that construction joint. Eventually it breaks down, and somebody has to come back and repair that fire rating with additional fire caulk typically. And then you have a cohesive failure or under application as well, where maybe they didn't put the right backer rod in, or maybe they didn't put enough mineral wool in behind there, and maybe that resulted in them not having enough caulking material to fill the joint. And as it cures, again, it shrinks. So therefore we commonly see, holes and imperfections, voids in that material, and those two have to come back and be repaired. And then finally, we also talked about substrate failure where, we're attached to a cut piece of gypsum board or something of that nature. And as the material dries and cures, it kind of pulls up away from that gypsum board, because it's difficult for it to stick to that, that gypsum dust, so to speak. Drywall rips. Again, this is what the video was highlighting with the T-shaped track. So I'll define that a little better here in this slide. You can see we have 2 layers of wallboard going full height of both sides of the wall stud. That 2 layers of wallboard indicates a 2-hour fire-rated wall assembly. You can see we have 2 drywall rips on each side of the wall stud assembly as well. That's just carrying our 2 layers for that 2-hour rated wall assembly. And then you can see up at the top, we still have our mineral wool flute plugs filling the voids of the deck. At the bottom of the deck, at each one of these valleys of the deck, they will have to install a little bit of fire caulk there, just because there's no intumescent tape on this T-shaped track. And then you can see the clip that I highlighted during the video, or after the video as well. Again, that clip is intended on both sides of the wall stud. It catches the return. It's positively attached with screws, so that it just helps to restrict those reaction loads that we receive at the top of wall track. We do have load tables with or without those clips. It's just when you add the clips in, it obviously increases the load capacity at the top of wall there. Perimeter bead, this bead here is a compressible fire stopping material that has a 1 and 2 hour rating. You can see there's no intumescent tape on this slotted track here. It's just bare standard slotted track. The perimeter bead has fire stopping materials in it, therefore up to 3/4 of an inch of total movement. You can get a 2-hour rating just with the bead stapled or mudded into place on the wallboard. Now we'll talk more about steel intumescent fire stops. So we have UL assemblies that permit the intumescent fire stop to either be factory applied, which is the slotted track piece that you see up there in that slide with the material already applied to the slotted track. We can do that in our steel factories, where we do apply the head of wall fire rating in the form of intumescent fire stop right in the factory. But our ULs also do permit field application as well. So we do also sell intumescent tape in rolls to be field applied as well. You can see some of the benefits are you can inspect during framing inspection for your fire rated head of wall assembly, because you can see the black strip. And the key with intumescent fire stop is you just want everything to be butted tightly together so that it's continuous everywhere. And you can see during framing inspection the large black strip on both legs of the track. So you can see that the fire rating is essentially intact. Once the wallboard's installed, it'll be installed overlapping of the intumescent tape. Typically, it's a little more than half the width of the intumescent tape is the overlap, and that allows you to maintain when that construction joint opens up in its cycling, you still have the gypsum board overlapping of the intumescent tape there as well. Some of the other benefits are it eliminates any rework in the field. It eliminates any misapplication of fire caulking materials. It eliminates any breakdown in the joint because the wallboard just rides up and down the intumescent strip. And it also provides solutions for beam obstructions and things of that nature where those areas can be difficult to get up into in order to fire caulk or fire protect. Some other advantages, it's a composite assembly that's positively attached to the structure. The intumescent comes in a cured state. It is protected from degradation and unaffected movement. There is a small liner over top of the intumescent material to protect it. It's just a clear liner so that that also allows the wallboard to ride up and down that intumescent tape a little more cleanly. The result of that is no fatigue to the composite profile or the surrounding substrate material. It's single source responsibility. The carpentry firm or the drywall installer is at this point now responsible for the fire rated head of wall assembly as well. They don't have to rely on a separate subtrade to come and carry that out. We do have the leakage ratings listed within the UL assemblies. Those are our smoke ratings. We'll show you that here in a minute. And it's one profile. If it's a factory meter dosage, we are applying that with adhesive in the factory, so you don't have any concern for that material to become compromised or falling off the track or applied incorrectly. When it's applied in a factory controlled environment, you just get a little more consistency in that application. And then finally, it provides consistent protection and movement capabilities, which are expressed in all of our UL assemblies as well. Here you can see what the intumescent does after a fire test. This intumescent tape at 375 degrees starts to expand, and it'll grow to 35 times its cured size. So that's why you see it after a fire event over that slotted track where it's really grown and it's overlapping now with the mineral wool flute fill that was installed there as well. You can see at the slide on the right, we actually tested two assemblies. We tested a vertical and a horizontal application at the same time during the UL burn. And you can see the intumescent material, how it comes in the upward direction to overlap that mineral wool flute fill. And then you can also see how it comes in the leftward direction there as well to overlap as well so that everything is completely protected there. We also do have fire-rated control joints. This is a composite control joint with intumescent tape factory applied to the V on the control joint itself. And you can see that black strip there at the bottom of the V on that control joint profile. The result in this is it eliminates the drywall rips in behind the two studs in the control joint. You can see here in the traditional method, you have two studs in there with two rips of drywall installed directly behind the control joint. And then with the fire-rated control joint with the intumescent tape, which is the picture on the right-hand side of the slide, you can see the intumescent tape in there, which eliminates those two rips of drywall. So we just take a little bit of labor out of there. These can be installed, if the control joints need to be cut in after into a fire-rated wall as well. You could install them after the fact as well, as long as you have the two studs backing the joint area. You do not need the drywall rips in behind that area. Now we'll show you some construction details of the intumescent fire stop used in different construction assemblies. You can see here, this is a 2-hour with 2 layers of wallboard overlapping the intumescent tape, and you can see we're up to a flat concrete deck. You can also see a shaft wall assembly. This is similar to the picture that we showed you early on. This does not have the mineral wool installed in the top track yet. However, in the detail there, in the section detail, you can see that it's detailed with the mineral wool, and that mineral wool then keys up over the liner board. With your intumescent tape on the outside of the track, that eliminates any fire caulking requirement above the liner board. So you have your mineral wool protecting you for leakage, and you have your intumescent tape protecting you from a fire standpoint as well. Here you can see perpendicular to a fluted deck. That could be a fluted metal pan deck. It could be a fluted precast deck with mineral wool flute fill only. Again, we rely on compression. These UL assemblies were tested with that mineral wool being compressed 33% of the way. What does that exactly mean? Typically for a 3 by 5 inch deck, you'd have a 4 inch by 6 inch flute plug to fill that area. That results in your 33% compression, and that is detailed in the head of wall UL assemblies as well without fire spray. Here you can see an example of a beam drop where we framed all the way around the beam that is obviously completely fire protected. And then you have your steel track with intumescent tape, and then you have actually a steel stud with intumescent tape field applied to it as well. And then you have your steel track at the underside of the beam, and then you have your intumescent tape there as well. And then you have your intumescent tape running vertical on the other side of the beam. So the whole beam is completely fire protected. The framing is fire protected with the intumescent tape boxing out the beam. And then we have our mineral wool flute fill, which is protecting for leakage between the framing and the web of the beam, essentially. Typically what they'll do is they'll shoot a piece of L angle to the web of that beam prior to the fireproofing being installed, and then they'll pack the wool out to the framing, giving it something to bear on in the middle there with that piece of L angle to achieve that 33% compression that we need in order to carry out that UL assembly. I mentioned early on fluted steel plates, and that's what you're looking at here. I do realize in the picture it's kind of difficult to see, but you can see the green highlighted rectangle there. That's the area that we're talking about. And if I were to describe this, you simply just have a steel stud framed wall running parallel to or with the flute opening. In those conditions, we do manufacture and have tested for UL these flute plates where you have the ribs of the flute manufactured to the exact distance of the flute opening itself. The end result is when you're using steel track with the intumescent tape on it, you only need to stuff 4 inches at each end of the wall to maintain the UL assembly. So if you have a 30-foot long wall assembly running with a flute opening, you don't need 30 feet of stuffing. You only need 8 inches of stuffing. So you only have to close off each end of the wall because we have these ribs in the flute plate out tight to the sides of the deck. And again, that is tested for fire and for smoke per UL as well. We also have vertical or wall-to-wall conditions as well. Here you can see the steel track, the intumescent tape up to a flat concrete deck, but then you can see the steel track coming down vertical as well with the intumescent tape on it also, and that's tight right to the concrete column. So we do have that vertical UL rating as well. Bottom of wall conditions. Finally, we also have the bottom of wall condition, whereas if they're going to hold the wallboard up due to gypsum pour or something of that nature on the floor, but it's a fire rated wall assembly, you can install track with intumescent tape at the bottom of the wall as well, so they don't have to come back and fire caulk that. We'll talk about some of the UL ratings of the joint assemblies now. This is addressed in IBC 2021, Chapter 7, Fire and Smoke Protection. It talks about the fire-resistant joint systems to protect voids at exterior curtain walls and fire-resistance-rated floor intersections shall be listed with the following criteria. Your joints installed in or between your fire-resistance-rated walls, floor ceiling assemblies, and roof ceiling assemblies by an approved fire-resistant joint system. There's also language in here that states that it's designed to resist the passage of fire for a time period not less than the required fire resistance rating of the wall. So if you have a 2-hour fire rated wall assembly, that's how long the joint intersection needs to be able to withstand the fire event as well. And then finally, you can see that these systems are to be tested in accordance with ASTM E1966 or UL2079. And UL2079 is the test method that we follow. ASTM E1966 kind of defines that test method, It talks about the performance of the joint systems designed to be used with the fire-rated floors and walls during that fire endurance test exposure. It also talks about the heating conditions, the methods of the test, and the criteria for evaluation of the ability of the joint system to maintain that fire resistance. And then UL2079 is the actual test standard or the testing protocol for those floor-to-floor, wall-to-wall, etc. Joint systems. You can see it dictates elements like where the thermocouples, I like to call them heat sensors. UL2079 dictates where those thermocouples are located, and that's what monitors the heat transfer through the assembly. Fifth edition of UL2079 is the newest version. That fifth edition came about for IBC 2021. So for projects that are permitted under IBC 2018 and previous, there's a prior edition, which is fourth edition UL2079. So we do talk about both of those in this presentation here as well. We'll get to that in a minute. But in the meantime, we're kind of breaking out one of our head of wall UL assemblies that you see listed here. This is HW for head of wall, D for dynamic, meaning that head of wall joint assembly can receive movement, and then -0814. That -0814 defines how much movement that head of wall assembly is tested to take. And you can see in this example, 0814 is less than 0999, so it's less than or equal 2 inches is what that head of wall assembly is designed to take from a movement standpoint. We already talked about it being dynamic, being able to receive movement there as well. Something that we didn't highlight yet, but I'll talk about it real quickly, is in the UL assembly, we list the L rating at ambient and the L rating at 400 degrees. That L rating is the leakage rating, which is talking in terms of air leakage or smoke leakage. And we'll talk a little more about that, but the code required smoke rating is typically less than 5 cubic feet per minute per square foot. And the L ratings for these intumescent tape products are all going to be less than 1, so they significantly exceed the code requirement there. We also have movement capability. The movement is based on how often and at what frequency this assembly, this head of wall assembly, it needs to be cycled. So we have a class 1, which is the least intense, which is a minimum number of 500 cycles. And then but it's only 1 cycle per minute. Then you have a class 2, which is 10 cycles per minute across those 500 cycles. Then you have a class 3, which is 30 cycles per minute across just 100 cycles. So what those really mimic during a UL test is, one would be like expansion and contraction due to thermal events. 2 would be like wind sway, so more frequent, considering the 10 cycles, but not as frequent as, say, a seismic event. A seismic event doesn't last as long as, say, like a wind sway event, so that's why you see your number of cycles reduced to 100. But at 30 cycles per minute, that's a much more intense cycling of that head of wall assembly. So essentially, we have the movement capability for thermal, we have the movement capability for wind sway, and we have the movement capability for seismic as well, as what we're mimicking there through the UL test. So to get into UL2079 5th edition, what changed? We previously discussed how UL2079 dictates where the thermocouples are located in the head of wall assembly. 4th edition, which is on the right-hand side of the slide, again, that's for IBC 2018 and previous. So anything that's permitted under IBC 2018 and previous can still follow UL2079 4th edition. That thermocouple was in line with the outermost layer of gypsum board. So per UL2079 5th edition, UL chose to move that thermocouple or that heat sensor in tight to the leg of the track. So the end result is, you look at the right-hand side, the 4th edition test, you had the thermocouple just in line with the outermost layer of gypboard. As a fire event takes place, steel transmits heat, so that track becomes hot. And when the thermocouple is in line with the outermost layer of board, it actually made the 2-hour test easier to pass than the 1-hour test. Because in this situation, you have a 2-hour test with 2 layers of board, and you can see where that thermocouple was placed. When we move the thermocouple in tight to the leg of the track, the heat transmits through there more rapidly. Therefore, for 5th edition IBC 2021, we had to essentially insulate the gap on the unexposed side, and that's where our perimeter L-bead products and things of that nature come into play. Just to be able to get that to pass the test, we have to insulate that area. And we'll talk a little more about that in a few minutes as well. UL2079, the standards for certification approval. There's really 2 measured standards. It's your cyclical testing and your flame passage. And then the optional standard is the leakage or the smoke rating. However, the majority of building codes are going to require that leakage rating to be in there. So we just go ahead and then test for it under UL2079 anyway, since they provide us the option to do that. So the dynamic cycle test, again, I already guess I got a little bit ahead of myself here. I apologize for that, but level 1 is the least intense, mimicking a thermal event. Level 2 would be mimicking a wind sway event. And then level 3 is mimicking a seismic event. So it would be the most intense, but over a lesser amount of time there. Here you can see a joint that was opened up during a test. You can see the gypsum board still overlapping of the intumescent tape. Here you can see that clear protective film over the intumescent tape that does come, applied to the intumescent tape already. So it's already there. That's what allows this gypsum board to just kind of ride up and down that intumescent tape. It's common that movement capabilities are expressed as a percentage of the installed gap, and that's because if you have fire caulking material above the gypsum board, between the concrete deck above and the gypsum board, now you're restricting movement in that area. With intumescent tape products, you're not restricting any movement because there's nothing actually above the gypsum board itself, so that's able to freely cycle. The end result is with these intumescent tape products, you typically see smaller joint sizes with less material that has to protect that area. The optional air leakage smoke seal rating is listed in IBC 2021, and this defines it. You have to test with the requirements of UL2079 for air leakage. And it states that the rating shall not exceed 5 cubic feet per minute per lineal feet at 0.3 inches of water for both the ambient temperature and the elevated temperature tests. Why do we have water in there all of a sudden? It's because we heat this assembly up and then we put the fire out literally with the fire hose. So we have to maintain that everything is intact. So again, the code requirement is less than 5 cubic feet per minute, and the leakage rating for these intumescent tape products is less than 1, so we significantly exceed that code requirement. Here you can see the wall assembly is built and it's subjected to a 2-hour burn for a 2-hour fire test. You can see we heat up one side of the assembly to get the other side of the assembly to react. And you can see that's why one side around that beam penetration is red hot and the other side has not been exposed to that heat. So again, the purpose of the UL test per 2079 is to heat one side up to get to the other side to react there. Then we come in and we literally put the fire out, literally with the fire hose. This hose stream test is typically the most difficult part of the UL test to pass. And you can see we had that beam boxed out with our intumescent tape. You can see we have our beam up tight to a concrete deck for this particular test. And then we have the web of the beam packed out with mineral wool as well. Again, there can be no seepage or leakage of water coming through to the unexposed side. If there's even a droplet of water, they will fail the test. So typically this hose stream is the most difficult part of the test to pass. But we have passed it with these intumescent tape products, and that's how the ULs are built and tested through the entire hose stream process as well. Some design considerations, some good design practices to take into consideration is whether or not you have a dynamic or a static joint. Deflection requirements, overall movement, how much is the structure, how much movement is the engineer of record calling out for the structure to move? So what do you have to design for from a wall type standpoint? How much deflection does that wall type have to receive? Cyclical movement, is it seismic rated? If so, you have to have level 3 movement capability. Many of your fire caulk materials are going to be limited to level 1 or level 2, simply because you have material filling the joint and they can't move as well, and they can't withstand movement as long because you have material in the actual joint that's going to break down over time. Thermal protection and hourly ratings are considerations, as well as air leakage and smoke seal, the fatigue of the joint systems, and the life cycle. We do have life cycle testing built into these UL assemblies as well, and we have that information available as well if anyone needs it. Other things to consider: environmental forces, geographic location of the project. Seismic fault lines are all throughout the country, regardless of where you live. So a lot of times those have to be designed for, even in areas where those fault lines aren't as active. We still have to design for seismic at times, so that's something to be aware of. Live load and frequency of movement. How often's the structure moving? What movement capability does that put you into? What type of products do you need to look for? Dead load as well as a consideration, and concrete creep over the lifetime of the structure. The concrete continuously dries out. It kind of constantly moves a little bit. What does that look like? Do we have to design for some movement in that condition as well? So specifying deflection requirements and level of life cycle, that's going to affect what size profiles you use, what size steel tracks you use, whether they're slotted, whether they're just a deep leg, how big your gaps can be, whether, depending on if you're designing with fire caulk or with intumescent tape, are those gaps encumbered. If they are, for example, with fire caulk materials, then those gaps are most likely going to be larger. The intumescent tape products allow you to really shrink that gap size because there's nothing encumbering the joint area. It can move more freely, resulting in that level 2 and level 3 movement capability. Other factors to consider: thermal, leakage ratings, adhesive properties of the fire stop materials. That really comes into play when you talk in terms of fire caulk and what it needs to adhere to. If it has to adhere to gypsum dust or to concrete deck, those dusty scenarios can make it difficult for that material to do what it's intended or designed to do. Also with the intumescent tape products, whether it's factory or field applied. If it's factory applied, we are cleaning all the oil off the steel in the factory. We are spray applying an adhesive, and then we are also applying the peel and stick intumescent tape as well. We're putting it on with a mechanical kind of ironed on process, where we're adhering that with a certain amount of pressure to make sure that it's absolutely going to stick and it's not going to fall off during or after construction. And finally, the longevity of materials is certainly something to consider as well. How long can those materials stay in that joint without breaking down? The intumescent tape is there without any consideration for breakdown because it's a completely unencumbered scenario. Hopefully by now you have a better understanding of fire and smoke rated joint assemblies, also UL2079, and to summarize, UL2079 for 4th edition and UL2079 for 5th edition. Again, UL2079 5th edition is an IBC 2021 requirement. That would involve you installing a perimeter L bead, as you saw in some of the construction details as well, to just insulate that area from heat transfer. UL2079 4th edition is IBC 2018 and previous, and that does not require that perimeter L bead, and is still being built to projects permitted at IBC 2018 and previous all throughout the country. One thing that I did not touch on is these intumescent tape products have been around for a number of years now, since around 2010, 2011. So they've been out there for a long time, being used in head of wall and bottom of wall and wall to wall construction joint scenarios. So that's something to consider as well. And we have head of wall UL tests around both 4th edition UL2079 and around 5th edition UL2079, and we can provide you with those UL test numbers if need be as well. So with that said, that concludes the AIA portion of the fire-rated head of wall joint assembly presentation. I'll kind of turn it over to Bo here real quickly to see what questions we had that came up during the presentation.
All right, awesome. Thank you so much, Matt. Great presentation. We've got quite a few questions in here, so we're gonna get through what we can get through. We've got about 10 minutes, so it should be a good amount of time, but if we don't get to your question, we do have a record of it. Looks like there are a few folks asking if they would be able to receive a copy of the slides for this presentation. Is that something you're able to share?
Yes, absolutely. We will just share that in a PDF format for them.
Okay, great. All right, next up, do you have detailing for rated wall assemblies in PEMBs?
In PEMBs, can you be more specific on the PEMB requirement?
Yeah, Christopher, I think you asked that question. Feel free to chime in the Q&A with a little more context. All right. Are there ever any issues with shipping or handling damage to the intumescent tape that is factory applied to head tracks? Does that make field application more desirable?
Not typically. We nest these materials in together so that they're kind of protective of themselves. We also wrap those skids to protect the material. An example I can use of a real life project that started construction with these intumescent tape factory applied steel tracks about a year ago is Indianapolis Hospital out in Indianapolis, Indiana. And that material sat out there on that job site. Granted, it was protected from the snow in the winter because it was inside the building, but that building was not heated and there was no concern for breakdown of materials due to temperature variations. There was also no concern due to breakdown of materials based on shipping and things of that nature. So typically we protect them very well during packaging. If that situation should arise though, they can field apply tape to make corrective action to the materials that were possibly compromised, but that's not something that typically comes up.
Mm-hmm. All right, great. Looks like we did get a little more context on that PEMB question. So Chris had asked, do you have detailing for rated wall assemblies in PEMBs? It looks like some folks chimed in. That's a pre-engineered metal building. And it seems like, yeah, a pre-engineered metal building at head of wall and exterior walls at wall girths, stud wall connections.
Yep, so I'm very familiar with pre-engineered metal buildings. Our UL assemblies head of wall are going to be specific to flat concrete deck or fluted pan decking, which is kind of uncommon in some of those pre-engineered metal buildings. However, if you have fluted conditions up at the roof line or if you have framing up to structural steel, I-beams or girts, our head of wall UL assemblies should apply there as well. So you should be able to take some of our UL assemblies and apply them to the pre-engineered metal building scenarios as well. It just depends on what the detailing looks like there.
Awesome. All right, great. Next up, do you also have ULC or CUL listed assemblies on your website for compliance to Canadian codes?
So yes, actually in those head of wall ULs that were in the presentation, and I don't think the presentation did a good job of explaining this, but they're certified for both. When you go into UL Product IQ and you look up one of our current head of wall UL listings, it's going to have the standard and then it's going to have the Canadian, both listed in the header of the UL at the top of the page.
Awesome. All right. How does the use of intumescent tape affect code required special inspection scope?
Yeah, so great question. We typically encourage inspectors to inspect the intumescent tape during the framing inspection because that's when they have the best line of sight to make sure that the intumescent tape is consistent. There are no gaps between profiles. There are no gaps between the deck and the intumescent tape on the steel track, and it's very easy to see because you have a large strip of tape everywhere. Now, when the wall board's applied over the stud wall and over the intumescent tape, that's when the fire rating is officially complete. But if you can get a look at it during framing inspection, then get a look at it after wallboard's applied. You'll be confident that it's installed as required per the UL assemblies. So that's typically how we address it. We do have those conversations a lot of times. For example, like at the project in Indianapolis last year, I went out to the job site, met with the architect, as well as the inspector, as well as the construction reps from the general and subcontractors to walk them through some of the common assemblies and methods of inspection and things of that nature.
Awesome. Are 3-hour ratings available with intumescent options mentioned?
Yes, typically we have up to 1, 2, and 3 hour per 4th edition UL 2079. When we moved over to 5th edition UL 2079 for IBC 2021, most of those are limited to 1 and 2 hour though.
Okay. All right, great. Let's see. Would the architect typically specify the top of wall UL design number, or is it more common for the architect to have a generic requirement, such as a 2-hour fire stop, and the contractor submits the specific design during construction as part of the submittals?
It's a little bit of both. That's kind of a gray area. We do see it specified sometimes as a very specific head of wall UL design that the architect wants to call out and list within their specifications and their drawings. However, some of the projects, require 3 different methods in order for the project to receive state funding or something like that. So at other times, it might be a little more generic as well. So the short answer is we really see it both ways. If it's not specifically called out, we can guide you towards a head of wall UL assembly that'll meet the needs of your project, though.
Awesome. All right, let's see here. Are engineered judgments ever prepared for unusual events by Clark Dietrich?
Yes, that does come up. We typically provide letters for unique conditions where we have, say a steel track that's under a concrete beam and the steel track's cantilevered off the concrete beam. That comes up. Things of that nature come up all the time. Construction has a lot of unique scenarios, but we can typically apply our testing per UL to those field conditions and get to a corrective action via a letter or an engineering judgment or some advice as to how to carry out that detail and maintain within the realm of our UL tested assemblies. Yep.
Awesome. All right. Okay, in the dynamic details, I did not hear of roof uplift, which is prevalent during high windstorm events. With a 1/4 inch to a 1/2 inch tape overlap by the GWB, could place the GWB below the tape when negative pressure above the roof lifts the roof. Is that ever evaluated during UL testing?
It is in terms of the cycling test. So you have both compression, downward deflection, and then you have extension, upward deflection built into all of these UL tests. So yes, we do have that factored into the UL tests as well. However, your gypsum board is always going to need to overlap the intumescent tape, minimum 1/4 of an inch in order to meet the UL assemblies. The end result is in that uplift scenario, you're just going to have a tape size that's a little bit bigger if the uplift is a little greater.
So, all right, and looks like we've got about one left here, the few minutes. So Michelle says, thank you for a great presentation. Are there higher requirements for air leakage ratings in addition to the code referenced you typically see for healthcare projects for interior protected environment rooms that you could refer us to? And are there specifications that go alongside those that you can point us to, or are teams typically relying on that hose stream testing requirement? For example, ASTM E1969 air leakage rate for fan pressurization.
Yeah, so I don't have any specifics in that regard. What I can tell you is we would attempt to apply the leakage ratings built into our ULs at less than 1, which significantly exceeds the code requirement. I've always been advised that there is no 0 rating in those scenarios because it's air, it's smoke, it always sort of finds its way. So yes, we would refer back to our less than 1 rating listed within those UL assemblies. We don't have anything specific to address those other areas of concern, but it's something that we'd be glad to talk more about and better understand it with you if appropriate as well.
Awesome. All right, great. Looks like everyone else in here is just asking for some copies of slides. So we've got a record of those, and we'll shoot you an email after the event. Before everyone jumps out for the day, just want to send a reminder in the chat. We sent over some helpful links to go to the Clark Dietrich site on Acelab, book a meeting with Acelab. So feel free to grab anything from there that you might need after today's webinar. All right, awesome. That should do it for us. I want to thank everyone so much for coming out today and for asking so many great questions. And thank you, Matt, for an awesome presentation.
Excellent. And thank you all for your attention and your time, and really appreciate you taking an interest in what Acelab and Clark Dietrich has to offer. Thank you very much.
All right. Have a good one, everyone.
Take care.